In number 6, we're asked to find the acceleration of the system and the tension in the blocks. So the first thing I'm going to do is label my forces. I know that I have gravity right here. It pulls down at 98 newtons. I know that I've got gravity pulling down on this one at 196 newtons. And I also have a normal force pushing up at 196 newtons. So these are the forces that I know. This block is pulling this block forward here at a force of 98 newtons. That's the pull. Now, I can find my acceleration. Because these cancel, F equals ma. The force on this is 98 newtons. The mass, both of these masses are accelerating, so I use both of these masses 30, and I look for the acceleration a. So 98 divided by 30 is 3.27. So the acceleration is 3.27 meters per second squared. So this block is accelerating down 3.27 meters per second squared. As is this block. It's accelerating this way, 3.27 meters per second squared. Now to figure out the tension in the rope, you might think to yourself, isn't the tension just 98? It can't be. Because if the tension in the rope was 98, that gives you no acceleration. They equal each other. You can't have accelerate. In order to accelerate down, this actually has to be less than 98. So we're going to erase this. We know that it's smaller than 98. We'll call it the force tension. Just like in number 5, I'm going to focus on just this situation right here. So if I go, my force equals my mass times my acceleration. I've got two forces. I've got a down force, and I've got a force opposing that, my tensile force. The mass of it is 10, and the acceleration is 3.27. So if I take 98, 100 times 3. So it's 32.7, and I subtract 98, I get a negative number. Solving for the force of tension comes out to be 65.3 newtons. 65.3 newtons. That's the force that's on the rope.